Okay, so this class is called statistics, okay? And we've talked about statistics for the first week of class. Now we're on the second week of class. What we're actually doing is we're switching subjects. We're gonna go to a different subject called probability. You're gonna be like, wait, but I'm just trying to take statistics. What are you doing to me? Well, the truth is statistics and probability, even though they are different subjects, they're super closely related. So you can't really do one without the other. Well, maybe you could do probability without statistics, but statistics without probability, you can't really do, because when you do statistics problems and you get answers, when you calculate answers, you're not going to understand what they mean if you don't understand probability. So for that reason, we're going to probability. Probability is the math behind the scenes of statistics, okay? And so what we're going to do is we're doing probability now. It's not the easiest thing in the world, and we're going to spend a lot of time on it. So chapter 5, 6, 7, and 8 is all probability. And once we get done with chapter 8, then we'll go back to statistics, and as we do it, when we calculate answers, again, we'll understand what the answers mean better if we understood what probability is. Okay, so we're doing probability today. So it's a different subject than stats, and so it's going to have its own vocabulary words. So we're going to talk about some vocabulary words. Let's see what this says first. Okay, so because, again, probability is not the easiest thing in the world, so I'm going to teach it slow. Let's make sure we all understand it. Here's what you need to understand. In every probability problem, you're doing something. The problem's going to say you're about to do this, okay? Like you're about to flip a coin. You're about to roll a die. You're about to draw a name out of a hat. And the thing you're going to be doing can be very simple or it can be very complicated, okay? But just remember, in every probability problem, you're doing something, okay? That something you're doing has outcomes, has results. Like if I say you're about to flip a coin, then I can say, well, what results can you get if you flip a coin? Well, it could land on heads or it can land on tails. If I say you're about to roll a die, what are the outcomes that you can get? Well, it could land on a 1 or a 2 or a 3 or a 4, you know. Or if I'm going to randomly select a student in this class and ask them for their age, let's say, then an outcome or a result could be like 19 or 22. Okay, so these things I want you to keep in mind. So basically 3 things I want you to keep in mind. In every probability problem, you're doing something. The thing you're doing has outcomes or results. And what we're going to do is we're going to take one outcome, okay? So we're going to focus on an outcome or a group of outcomes. And I'm going to ask you, what's the chance that that outcome or this group of outcomes occurs? Okay? Every probability problem has these 3 kind of things in it, okay? And again, the thing you're going to be doing could be something very simple or something very complicated, but every probability problem is structured like this. In every probability problem, you're going to be doing something, that something has outcomes, and I'm going to focus on one outcome and say, what's the chance that outcome will happen? Or instead of focusing on one outcome, I might focus on a group and say, what's the chance one of the outcomes in this group happens? Okay. So let me give you some definitions then. The thing you're doing is called the experiment, okay? Remember, in every probability problem, you're doing something. The thing you're doing is called an experiment. Don't think of an experiment as in like in a chemistry class or in a physics class or something. In a stats class, an experiment is whatever the thing is that you're about to do. If I'm about to flip a coin, flipping a coin is the experiment. So an experiment is a procedure that results in a list of outcomes. It's the thing you're about to do. Also over here, it says something about repeatable. Every experiment should be repeatable. Like if you flip a coin, you should be able to do it again and again and again if you wanted to. If you wanted to flip a coin 1,000 times, you should be able to. If you're going to roll a die, again, same thing. You should be able to do it over and over again. It's not like you roll the die and then after you roll it once, it breaks and you can't roll it again kind of thing. So it should be repeatable, and the chance for all the outcomes should stay the same every time. Like, you know, it's when you flip a coin, there's 50% chance it lands on heads. After you flip the coin, it should still be 50% chance the next time. Okay? If for some reason you flip the coin and something happens to it and now the chance of heads has changed, that's not what we want. So every experiment needs to be repeatable, and all the chances for all the outcomes need to stay the same every time you repeat the experiment. Okay, then if you take all the outcomes of the experiment and you make a list of them, that's called the sample space. Okay, so sample space is a list. What is it? It's a list of the outcomes of the experiment. Which outcomes? All of them. Okay, so it's a list of all possible outcomes of the experiment. The notation is capital S. So we'll do examples in a minute, but you know, like on the quiz next time, I might say find capital S, and I might not tell you what that means. I need you to remember that when you see capital S, that's sample space. You have to make a list. And which outcomes do you list? all of the possible outcomes. Okay. And then we have this word event. An event is also a list. It's not a list of all the outcomes, it's a list of some of the outcomes. It's a list of some possible outcomes of the experiment. The event is the list of outcomes that we're going to find the probability for. So remember, in every probability problem, you're doing something, which we're calling an experiment. That thing we're doing has outcomes. This is the list of all those outcomes. And I'm going to focus on one outcome or a group of outcomes, that's what this is, and ask you, what's the chance that that happens? Okay, so that's the idea there. Remember that when I ask you for an event or for the sample space on a quiz, you're going to be making a list. Okay, you're going to list. For sample space, you list all the outcomes. For the event, you list some. Which ones do you list? The ones we care about. Okay, if I say, what's the chance that this happens? All the things in the part, all the outcomes in what I care about is what you list. You'll see, we'll do an example in a minute. Okay, and then we have this word also. We say an event occurs if one of the outcomes in the event occurs. Okay, so an event, again, is a list of some outcomes. But remember, when you do an experiment, only one outcome can happen. So if you have a list of 5 outcomes, well, we say that entire list occurred if anything in it occurs. Okay, so if you do the experiment, like let's say your list is, 2, 4, 6. Let's say you're rolling a die, and that's your event, 2, 4, 6. And you roll the die, and it lands on number 4. Did this event occur? Yes, because 4 is in there. If it's in there, we say the whole event occurred. If I roll a die, and it lands on a 6, did this event occur? Yes or no?
Yes.
Yes. If it's in there, we say the entire event occurred. Like, these can't all happen when you roll the die once, okay? But if any one of those happens, we say the event E happened. Another way to say it is, imagine you're betting and you'll win if one of those occurs. So if you roll a 2, did you win? Yeah. Okay, so if it's in there, it occurred. If you roll like a 5 or something, did this event occur?
No.
No, because it's not in there. Okay, so if the outcome of your experiment is on the list, then we say the entire list occurred. If it's not on the list, we say the entire list didn't occur. All right, so here, we're gonna do a bunch of examples. So we gotta do a ton of examples on this. So we'll do a bunch. And then I have a bunch more for you to do for homework, so there's a ton to do. Okay, when you're doing these problems, you wanna be really clear. You wanna read it and really understand what's going on. First, make sure you understand completely what the thing is that you're doing, what the experiment is, okay? And then make sure you're completely clear on what the outcomes look like. Let's see what it says here. The experiment in this problem is we're going to draw one ball from this bag. So we got this bag over here, we're going to draw one time, okay? And then we have all these events that we'll look at in a minute. And it says find all these things. So we have to find a bunch of events and stuff, and then we'll answer the question at the end. Let me make this smaller so we can do it. Okay, so let's start with S. Remember what S is? It's the sample space. You have to list all possible outcomes. Well, so when you make a list in here, you have to start with curly brackets. Please don't forget the curly brackets. Those are my curly brackets, okay? And then you list all possible things that can happen if you do this. So if you draw one ball from the bag, what's a possible result? 1 is a possible result, okay? Comma, 2 is a possible result. And you just list all the different possible results. Sample space, you have to list all the results. So you just list everything in the bag, basically. Make sure you put commas between the different things that can happen. And then curly brackets. Please don't forget the commas. Please don't forget the curly brackets. Okay, that's the sample space. Okay, then the next thing says find capital A. Let's read what A is. Here it is. You draw a ball with an even number on it. I'm giving you a verbal description of a list, and you're going to make the list. So you're not going to list all the balls in the bag. You're just going to list the even ones. So curly brackets. Whoa, okay. And then what goes in there? Someone tell me.
2, 4, 6, 8, and 10.
2, 4, 6, 8, and 10. Don't forget the commas. Don't forget the curly brackets. Yeah. So I'm just focusing on 2 things right now, okay? What is the thing we're doing? And let's go ahead and make some lists of some of the outcomes. Later on, I'll say, what's the probability, what's the chance that you get an even number, but we'll do that later. This is kind of like, this is the stuff I care about. I care about getting an even. Maybe I'm making a bet, and I'm going to win if I get an even. So I'm just listing the ways I can win, the things I care about. Let's go to B. E is the event that you draw a ball with a prime number on it. So now I have to list all the prime numbers. Now, if you don't know what a prime number is, let me explain it real quick. If you look at the number 10, for example, 1 goes into 10 and 10 goes into 10. But does any other number go into 10? Anything else?
5.
5 goes into 10. What I mean when I say go in, I mean, can you divide it without a remainder? Yeah, 5 goes into 10. So because something, okay, every number, 1 will go into it and it will go into itself. That's true for every number. But if there's anything else that goes into it, then it's not prime. So 10 is not prime because 5 goes into it. Also 2 goes into it. If anything else besides 1 and 10 goes into it, it's not prime. So 10 is not prime, so it doesn't go on my list. I'm supposed to list the things that are prime. If you look at 9, 1 goes into it, 9 goes into it. Does anything else go into it?
3.
3. Because 3 also goes into it, it's not prime. Let's go to 8. 1 goes into 8, 8 goes into 8. Does anything else go into 8?
4.
4, also 2. So that one's not prime. If you look at 7, 1 goes into 7, 7 goes into 7. Does anything else go into 7?
No.
No. So that's prime. So that's going to be on my list. Okay, 6. 1 goes into it, 6 goes into it. Does anything else go into it?
2.
2. That makes it not prime. So it's not on my list. Let's go to 5. 1 goes into it, 5 goes into it. Does anything else go into it?
No.
No. That means it is prime, so it goes on my list. All right, 4. 1 and 4 go into it. Does anything else go into it?
2.
2. So that's not prime. Let's go to 3. 1 goes into it, 3 goes into it. Does anything else go into it?
No.
No.
So it is prime. Let's go to 2. 1 goes into it, 2 goes into it. Nothing else goes into it, so it is prime. And then let's go to 1. Okay, now, 1 is a weird one, okay? So let me just say this. If I ask you guys if it's prime, most of you are going to say yes. And it's totally reasonable for you to say yes. But the answer is no, 1 is not prime. For no good reason, but I'll just tell you the reason. The reason is because, somebody defined this, made up this word prime. Somebody made it up, right? And whoever made it up said a prime number has to be bigger than 1. If you go and look up the definition of prime number, it says it's a number bigger than 1 where nothing goes into it other than 1 in itself, something like this. So long story short, 1 is not prime because the guy who defined the word prime said so. Okay, it's not a big deal, okay? But anyway, just so you know, 1 is not prime. So there's event B. Any questions on event B?
No.
Let's go to C. C is the event you draw a yellow ball. So again, it's a list. So you're going to put curly brackets. Basically, each one of these, I'm basically telling you which of these I care about, and you're going to make a list of the ones that I care about. Which are the ones I care about when I'm talking about C?
2 and 3.
2 and 3. So just put 2, comma 3, curly bracket. Okay, let's do D. Let me put it over here. So D. You draw a ball that's both blue and even. So those are the ones I care about in here, the ones that are blue and even. So you list the ones I care about. So tell me which ones.
4 and 6.
4 and 6.
4 and 6. Put commas and curly brackets. All right, let's go to E. This time, the ones I care about, because maybe I'm betting on it or something. You draw a ball with a number larger than 6. You have to list the numbers in the bag that are larger than 6. Tell me what it is.
7, 8, 9, 10.
7, 8, 9, 10. Again, don't forget the commas. Don't forget the curly brackets. Okay, and then part F, or event F. Let's see, here's F. You draw a ball that is less than 7. So it has a number on it less than 7, and it's also odd. What goes in there?
1, 3, 5.
1, 3, 5.
1, 3, 5.
Sometimes a student will say 7. I'm glad you guys didn't say 7, but it has to be less than 7. So 7 doesn't count. All right, so those are events. Any questions so far?
Do we have to write them in ascending order?
No. The order you write them in does not matter.
Okay.
I normally try to write them in order, but you do not have to write them in order, no.
Okay, thank you.
Sure, other questions? Okay, so we did this part, and now there's a question. It says if ball 2 is drawn, which of these events occurred? Again, think of it as like for this, think of this as like I'm betting, and these are the ways I can win. I'm only going to win if a 1, 3, or 5 come up. So if I draw 1, I won because 1 is in there. So if I draw 1, we say event F occurred. But if I draw 2, did event F occur? Oh, it's not in there. So if the outcome, remember, when you draw one time, you're drawing a single ball from the back, you're only going to get one number out of here. If the number appears on your list, we say the entire list occurred. Okay, so if we draw the number 2, if ball 2 is drawn, did this one occur? No. Did this one occur?
No.
No. So it's like I lost. Did this one occur?
No.
No.
No. How about this one?
Yes.
Yes. This one?
Yes.
Yes. This one?
Yes.
Yeah.
And I can even ask for the sample space. Yes, for that one as well. Another way to say it is, if I draw the number 2, did I draw an even number? Yes. And these are the even ones. A stands for evens. So yes, if I drew the number 2, I drew an even. There's other evens, but if I draw 2, I drew an even. Okay? If I draw the number 2, did I draw a prime? Yes, because 2 is prime. There's other primes, but as long as it's on the list, we say the entire list occurred. Okay. Let's go to 7 real quick. Same idea. So let's say you draw the number 7. Let's go starting from F. If you draw the number 7, did F occur?
No.
No. How about E?
Yes.
Yes.
Yes, it's on there. So if you draw the number 7, E occurred. Did event G occur if you draw the number 7?
No.
And I guess we might as well do it for all of them real quick. Okay, did event C occur?
No.
No.
We're focusing on the number 7 right now. Yes, it's a no. How about event B?
Yes.
Yes. A?
No.
No. Again, if you draw the number 7, did you draw an even? No. And you can see that by looking, it's not in there. Okay. And then the answer is yes. The answer is always going to be yes for the sample space because everything is listed there. Okay, that's example 1. We're going to come back to example 1 in a few minutes, but any questions so far on example 1?
No.
As far as if you're taking notes in a notebook right now, then what I advise you to do is leave some space because we're going to come back to this example. Leave some space. Okay, so just be prepared that will happen. Let's go to example 2. Okay, so now I'm just going to give you another experiment. Remember, every probability problem, you're doing something. I'm going to give you something else that we're going to do. We're going to do the same kind of question again one more time to make sure we get comfortable with it. This time the experiments were rolling a die once. You know what I'm talking about? Dice, but we have one only. Okay, so it's called a die when you have one only. So we're going to roll a die one time, and I'm going to ask you some questions. So we have a bunch of events again over here. I'm asking you to find them all, and then, yeah, so that's it for that one. So let's go ahead and do it. Okay, so here it is smaller. First, we're going to find the sample space. Remember, that's the list of all the outcomes. You put curly brackets. When you roll a die, list all the outcomes. What are all the outcomes? Someone tell me.
1, 2, 3, 4, 5, 6.
Okay, wonderful. I love how you said that. 1, 2, 3, 4, 5, 6. Let me explain why real quick. A lot of times students will say 1 through 6. Okay, if you say 1 through 6, understand that that's not clear. Okay, and you'll probably understand more later when we get to chapter 6. This is unclear because 1 through 6, do you mean only the whole numbers from 1 to 6? Could it be decimals? Does 1 through 6 include 4.85? Is that 1 through 6? So you see what I'm saying? So it's not clear. But when you just list them all, 1, 2, 3, 4, 5, 6, that's the best. Okay, so anyway. Let's go to A. So event A, here right now, the die lands on an even number. So you have to list the even numbers on a die. Make sure when you make your list, it's a result. Like 10 is an even number, but you wouldn't list 10 here because 10 is not an outcome when you roll a die. So you got to be mindful of what your experiment is. Okay, so what goes on this list?
2, 4, 6.
Wonderful. Sounds like you guys are getting it. 2, 4, 6. Don't forget the commas. Don't forget the curly brackets. Let's go to B. B says die lands on a multiple of 3. Okay, what are the multiples of 3 on the die?
6.
Yeah, well, it's 3 and 3 is also a multiple of 3, so 3 and 6. Okay, we good on that one?
Mm-hmm.
If you don't know what multiple means, it means it if you divide the number by 3, it'll go in evenly. So these are the two numbers on the die where if you were to divide them by 3, it'll go in evenly. Okay, C says the prime numbers. We already talked about prime numbers a lot, so let me just go ahead and list this answer here. 1 is not prime, 2 is prime, 3 is prime, 4 is not prime, 5 is prime, 6 is not prime, and don't go past 6. If you're ever wondering how far to go, you can always go back and look at the sample space. You've listed all the outcomes there, so every other event should be some of these. So you can just look through the sample space and go, which of these do I put on this list? Okay, but don't list anything that's not in the sample space because it's not even a possible result of your experiment. Okay, let's go to D. D says die lands on 4. What goes in there?
4.
4, yeah. Just 4, curly brackets, no commas. Okay, let's go to E. Die lands a number bigger than 2. You have to make a list of all the numbers on the die bigger than 2. What's the list?
3, 4,
3,
5.
4, 5, 6.
Cool, let's go to F. The die lands on 7. What goes in there?
Nothing.
Nothing. That's right. Okay. Let's talk about this for a second. Okay. Sometimes a student will write this, but it doesn't make sense. There's no 7 on the die. So please don't forget what your possible results are. 7 is not a possible result. So it's an empty list is what it is. Okay. So you can have an empty list. There's nothing in the list. There's 2 ways to write an empty list. Check this out. Okay. Before I write down the answer. One way to write an empty list is to put curly brackets and put nothing inside it. Okay, that's one way to write an empty list. But there's also this symbol that stands for empty list or empty set. Okay, so it's just a symbol reserved for empty list. That's the one I prefer you use, but you know, if you did the top one, that's fine too. So curly brackets, nothing inside, or use this symbol. Now, don't do this. Sometimes students will do this. This is not the right answer. Think of a list as like a box, okay? So this is a box with the numbers 3, 4, 5, and 6 in it. Here's an empty box. This is also an empty box. This, though, is not an empty box, okay? This is a box that's telling you that it's a box that has an empty box in it, okay? So it's not an empty box, this thing. So don't write it that way. Okay, so this last way, don't write it. I get why a student would write that because I keep saying don't forget the curly brackets. But for the empty list, only that one, you don't need to put any curly brackets, just use this symbol. Or again, you can use, but don't use this one. Let's just use this one. This is the one, the standard one to use. Also, one more thing to mention, sometimes when students are writing the number 0, they'll just put this there. Please don't do that. If the answer to some problem is 0 and you write this, you're going to lose points because you didn't write 0. You wrote the empty list, okay? Like I was grading something the other day and someone wrote 30 and they wrote it like this. I let it go, but I'm not going to let it go in a stats class because this does not mean 0, okay? So please don't write your zeros like that. Okay, so that's F. Any questions so far? Okay, let's look at G. Die lands on a number less than 9. Each one of these, I'm describing a group of outcomes of your experiment. Eventually, I'm going to say, what's the chance of it happening? Right now, I'm just describing a group, and your job is to list the things in the group. So you put curly brackets, list the numbers on the die that are less than 9. Which numbers on the die are less than 9?
2, 3, 4, 5, 6.
Yeah, all of them. 1, 2, 3, 4, 5, 6. They're all less than 9. You list them all. Turns out that G is the same thing as the sample space because you've listed everything. And that's what the little hint on the bottom says. It says one of the events above is the same as a sample space. That's this one. It turns out to be the same as a sample space. And another one is the empty set. This is the one that's the empty set. Okay, cool. We're done with example 2. Any questions on example 2? I'm just going to leave this here. Just like example 1, we're going to come back to example 2 again. So if you're taking notes in a notebook or whatever, leave some space because we're going to come back to this. Okay, so in every probability problem, you're doing something. That thing you're doing is an experiment. and it's going to have outcomes, okay? We're going to focus on one outcome or a group of outcomes, and I'm going to say, what's the chance that that outcome or that group of outcomes will occur, okay? So right now, I just focused on two things. What's the experiment and groups of outcomes. But now we have to talk about how do we figure out the chance of it occurring? Okay, like what's the probability if we roll a die, what's the probability it lands on an even number? What's the probability it lands on a number bigger than 2? What's the chance of these things happening? And that takes us to our next word, probability. So we already had 3 words, experiment, sample space, and event. And now we have the 4th one. This is the last word for the day. Most important word though, probability. Make sure you guys understand probability is not a list or anything else, it's a number. It's a number, and it tells you the chance of an event occurring. Let's see what it says over here. So a probability is a number assigned to an event. In other words, I have to give you an event first. I have to give you a group of outcomes first, and then say, what's the chance this event, this group of outcomes will occur? Okay. So it tells you the chance that the event will occur. Okay, probabilities are numbers. They're always between 0 and 1 or between 0% and 100%. When you write probabilities, if you write it as a percentage, then it's always going to be between 0% and 100%. If you write it as a decimal, then probabilities are always between 0 and 1. 0% as a decimal is 0. 100% as a decimal is 1. So the answer will always be between 0 and 1 or 0% and 100%. Okay, now some notation. Notation is very important today, guys, and it's going to be even more important the next couple days. So really focus on the notation because I'm going to be looking for it when we do problems. Okay, so first of all, usually we use a capital letter for an event, but if I want the probability of that event, I'm going to put a P in front of it. This is the notation for probability of the event. So you'll see a P outside, P stands for probability, and there'll be a parentheses. And inside the parentheses will be that group of outcomes, the event we're trying to find the probability of. So this right here is an event, it's a list. This right here is the probability of that event, it's a number, okay? I'm gonna show you how to calculate it in a minute. One more bit of notation. If E is an event, the number of outcomes in the event is denoted by absolute value of E. So remember, E is an event, capital letter is an event. If I put an absolute value around it, I'm asking you to count how many things are in that event. So you just count the number of outcomes in the event. That's what absolute value of E is. Okay, now as far as calculating probabilities go, there's two main ways we're going to focus on for calculating probabilities. The first one is called the classical method. This is what we're going to focus on for the next, I don't know, 20, 30 minutes or so. Classical method for calculating probabilities. Okay, first of all, this method for calculating probabilities does not always work. Okay, but it works often, but not always. When does it work? Every outcome of your experiment has to be equally likely for it to work. Okay, so like when you flip a coin, there's 2 outcomes, heads and tails. Which one has a higher chance of coming up, heads or tails? The answer is they have the same chance. Okay, when you roll a die, which which number comes up the most? 1, 2, 3, 4, 5, or 6? Well, the answer is they all have the same chance. The one that has a 1, the one that has a 2, 3, so on, they all have the same chance. And another example is you think of all the outcomes and go, do they all have the same chance of occurring? If they do, then you can use this classical method. So that's what it says over here. If each outcome is equally likely, every single outcome of whatever you're doing, of your experiment, if they all have the same chance of coming up, then define the probability of the event. What you're going to do is you're going to make a fraction. So you put a fraction line. Okay, now, whatever event you see in the parentheses, you're going to write it on top with an absolute value around it. Okay? And the bottom, you're going to put absolute value of S. The bottom is always going to be absolute value of S. This has to match this. This is always absolute value of S. This little formula that I'm writing here, I'm going to want to see that from you every single time we do a problem. Okay, so there's the formula. Now we're going to practice it. Here we go. Okay, we're back to example 1. Here it is smaller. Okay. So again, what's the experiment? What's the thing we're about to do? We're about to draw one ball from the bag over here. So we're going to draw once. We have all these events like we had earlier. And I wrote down what they were. I just copied them down since we found them earlier. Here's all the events that we found earlier. And now look what it says. It says find S, A, B, C, D, E, and F. We did that already. That's all this. And now I'm asking you this. find the probabilities of all these things. So I want to find the probabilities of all these events. Okay, so here we go. Let me change colors. Okay, I'm going to do this one last, probability of S last. So let's skip that for now. Let's go to probability of A. So probability of A, again, notation, formulas, all these things super important. So everyone check out what we're going to do. What you're going to do to find the probability, well, actually, first thing you should do is make sure you can use the classical method. When you draw one ball from this bag, do they all have the same chance of occurring? Like, does every ball have the same chance as every other ball? Yes.
That's
What would make them not have the same chance? Well,
There's-
maybe if the number 2 is in there more often, or maybe if some of the balls were bigger, some of them were smaller or something, maybe. But if they're all the same size and there's one of each, they all have the same chance. So then we're going to use the classical method, and the way you do it is you're going to put a fraction line. Whatever event you see in the parentheses, you're going to put on top with an absolute value around it. So you're going to put absolute value of A on top. On the bottom, you're always going to write absolute value of S. So that step there, you're losing points if you don't show it, and you're getting points if you do show it. Please make sure you show it every single time. Okay. And then let's continue. So now, what does it mean when there's an absolute value around an event? It means count how many things are in that event. Here's A over here. All you do is count how many things are in there. How many things?
5.
5. So you put a 5 here. Okay, there's an absolute value down here, absolute value of S. It means, absolute value means count. How many things are in S? Here's S, you have to count how many things are in S. How many?
10.
10. And that's it, that's the answer. This is as much as I want to see from you. I want to see this, and I want to see this. Now, if you want to keep going, if you want to simplify the fraction, or write it as a decimal, or write it as a percent, that's up to you. I do not need you to do that, but you can if you want. This is as much as I need to see these two things here. Okay, that's it. So now, before I do the rest of them, just a couple things to watch out for. So sometimes when students get to this step, they'll leave off the absolute values, and they'll write this. This makes no sense. This is what I'm trying to say. Communication, notation is communication. And if you get it wrong, it doesn't make sense what you're writing. Because what is A? It's an event. It's a list. What is S? It's a list. Again, these are both lists. What does this mean? Fraction line, that line basically means divide. What kind of things do you divide? You divide numbers. You don't divide lists. If I give you 2 lists of names or something, and I say, here, divide them, what are you going to do? Doesn't make sense. Okay, so don't do that. Okay, make sure you put the absolute values. Also, sometimes I get students, instead of writing absolute values on each one separately, they'll just write an absolute value around the whole thing. This doesn't make sense either for the same reason. Because if you write it like this, it first means divide, and then we'll deal with the absolute value later. But again, you're dividing lists. It doesn't make sense to divide lists. It only makes sense to divide numbers. So you have to write it like that. Absolute value of the parentheses event on top, absolute value of S on the bottom. And the third thing that I see students do sometimes is when they're trying to, like, okay, let's say you got to here, and then now you're counting. And when you count absolute value of A, you go, oh, there's 5 things. Sometimes students will write 5 with an absolute value around it. Okay, this doesn't make sense. Okay, because absolute value means count. Once you've counted, don't write the absolute value anymore. If you've counted, you've done the absolute value. So then you should not be writing absolute value. So don't be writing your answers like this. Okay, sometimes I'll see students write that. Okay, don't write that. Absolute value means what? It means count. Once you've counted, go ahead and just write those numbers there, no absolute values. But again, after that, I don't need you to do any more. You don't have to simplify the fraction unless you want to. You don't have to write as a decimal or a percent, but you can if you want. All right, let's do probability of B. So, okay, same thing. First of all, fraction line. So we're going to write the formula first, fraction line. What am I going to write on top? Someone tell me.
the absolute value of B.
Right. Whatever's in parentheses, write it on top with an absolute value around it. On the bottom, you're going to write absolute value of S. The bottom is always absolute value of S. And then you start counting. Okay, absolute value of B means count how many things are in event B. How many things are in there?
4.
4. Absolute value of S means count how many things in S. How many things?
10.
10. So for all these problems, the bottom is going to be 10 because the bottom is always absolute value of S, and we have 10 there. Okay, that's probability of B. Let's go to the next one, probability of C. So again, first thing you write, fraction line. Then what do I write on top as far as the formula goes? See?
Absolute value of C.
Absolute value of C, yes. Okay. What goes on the bottom?
Absolute value of S.
Yes.
Absolute value of S, yes. Okay. And again, absolute value means count. So you have to count how many things are in C, then you got to count how many things are in S. How many things are in C?
2.
2. And then there's 10 things in S. Okay, so that's how you do that one. Go to probability of D. Actually, I guess I have room. I could do it over here. Okay, probability of D. So one more time, fraction line. What goes on top?
Absolute value of D.
Absolute value of D. Bottom?
Absolute value of S.
Absolute value of S. Okay, now absolute value of D. Here's D. What's absolute value of D?
2.
2. Yes. Absolute value of S?
10.
10. Yeah. Okay, let's go to the next one. Probability of E. Okay, formula fraction line. On top, absolute value of E. Bottom, absolute value of S. You count how many things are in E, there's 4. Count how many things are in S, there's 10. Okay, last one. Probability of F. Top is absolute value of F. Bottom is absolute value of S. And again, you count. Absolute value of F means count how many things are in F, there's 3 things. Bottom, count how many things are in S, there's 10 things. And that's the story on example 1. And I didn't do probability of S, I'll do it right now. So any questions on this much? Since I ran out of room, let me do probability of S up here. Okay, so one thing to know, the probability of the sample space is always 1. So you can memorize that, which you should, and you don't have to show me any work for that one. Probability of S is always 1. If you don't want to write 1, you can write 100%. So 1 or 100%, either one, you can just write the answer and show no work. But I'm going to show work just so you see, if you were going to show work, what the work would look like. So whatever event you see over here, you have to put on top with an absolute value. Okay, so since there's S, you put an S up on top. The bottom is always absolute value of S. From there, you can see that they cancel and you get 1. If you don't see that, then you can keep going and go, well, absolute value of S is 10, and absolute value of S is 10, and you divide and you get 1. So there's the work, but you do not need to show it. In every single problem, it will be 1. So you can just write 1, no other work. But only for probability of S. Every other one, I need to see the formula and then the answer. Okay? So you can write, and so for probability of S, you can write 1 or you can write 100% without showing any work, but only for probability of S. Any questions on example 1? All right, let's go to example 2. So again, we already did example 2, but now I'm adding some probability questions to it. Okay, so in this experiment, we're rolling a single die once. That's the thing we're about to do. And here's a bunch of events or groups of outcomes, and I want to find the probabilities of these events. So here are all the events that we found earlier, and I'm going to find the probabilities of these events. So let's start with probability of A. So I'm going to skip probability of S for now. Probability of A. Again, the formula is fraction line. What goes on top?
Probability of, absolute value of A.
Right, absolute value of A. Okay, bottom.
Absolute value of S.
Right. And again, what does absolute value around an event mean? It means you need to count how many things are in that event. Here's A. Let's go ahead and count. Things are in there. What?
3.
3. What's absolute value of S?
6.
6. In this problem, there's 6 things in S. Yeah. Cool. So again, I must see this and then this. If you do anything further, it's up to you, but that's what I need to see. Any questions? Okay, let's go to the next one, probability of B. Okay, again, fraction line. What do I write on top as far as the formula goes?
Absolute value of B.
And bottom is absolute value of S. And you count, what's the answer?
2, 6.
2 over 6. Yep. All right. Let's do the next one, probability of C. Okay, so fraction line, absolute value of C, whatever's in there goes up on top with an absolute value around it. The bottom, absolute value of S. And we count, we got 3 things here, we got 6 things here. Okay. Probability of D. So fraction line, absolute value of D on top, absolute value of S on the bottom. How many things are in D?
1.
1. Be careful. Sometimes students will write 4. I get it. But you're supposed to count, and there's only one thing in there. So 1, 6 on the bottom. All right, let's keep going. Probability of E. Okay, someone tell me the formula, entire formula.
Absolute value of E divided by absolute value of S.
And then count and give me the answer.
4 divided by 6.
4 divided by 6. Yeah, cool. All right, you guys understanding?
Yes.
Okay. Probability of F. F is the empty set. That's another one. Those are, well, the sample space and the empty set, those are the only two where you can write the answer without showing any work. Okay? The probability of the sample space is always 1, and the probability of the empty set is always 0. So you could just write 0 and that's it, and I don't need any more work for that one. You could write 0% if you want for this, just like you can write 100% for this if you want. Either way, without showing any work. But if you were going to show work, I'm going to show work real quick just so you can see why I'm right, okay? But I don't need to see any work. Hold on. Okay. Okay, there we go. Okay, so if you were going to show work, it would go like this. Absolute value of F over absolute value of S. And now you count. Here's F. How many things are in F? How many things are on that list? How many? 0. And there's 6 things in S, and if you do 0 divided by 6, you get 0. So there's work if you wanted to show it. But again, you don't need to show it. Probably the empty set is always 0. Probably the sample space is always 1. Okay, so that's how that goes. For probability of G, well, G is the sample space, so we could just write 1. Or again, if you were dying to show work, it would go like this. Absolute value of G over absolute value of S, and you start counting, you get 6 over 6, you get 1. So you can show work, but again, just save yourself some time. Anytime you find the probability of S, you just write 1, or you can write 100% if you want. And anytime you're trying to find the probability of the empty set, you can just write 0 or 0% without showing any work. But those are the only two. So these two, I don't need to see the work on. The rest of them, you must show the formula and then the answer. And we're done with example 2. Any questions on example 2? Okay, so a lot of the problems that we're going to be doing today in class, the 2 we already did plus some other ones, are in this document that I've called Supplemental Homework Problems. You could think of it as a worksheet, but it's not a worksheet you're going to turn in, but we're going to be doing lots of these problems. I'm going to post this worksheet in the assignments link so you can see it. You don't have to complete them all. You should complete them all for your practice. We're going to do a lot of them in class today, and some of them we're going to do in the in-class worksheet next class. But anyway, so I just want you to know when you're reading the problems and you see it says it's talking about supplemental homework on the top of the page. Okay, so a lot of the problems we're going to be doing is from this worksheet. So just so you're clear. Okay, so there's a whole bunch of problems here. And again, a lot of the ones we're doing in this video come from here. Again, I'll post this in the assignments link. And also, again, some of the in-class, when we work on the in-class worksheet, we're going to get more problems coming from here. And again, if you have, when you're studying, if you're like, I don't know what else to study, you can go get this worksheet or supplemental homework assignment or whatever you want to call it and practice more problems. But again, this worksheet on its own is not going to be submitted. It's just there for more practice. All right, so in this example, it says we're going to flip a single coin 3 times or flip 3 coins all at the same time. And it's going to ask us to find a bunch of stuff. And the first stuff that we're going to find is the sample space, S, and the probability of S, and the probability of the empty set. Okay, before we get to finding it, I need to talk about this experiment a little bit. The most important thing in any probability problem is for you to read it carefully and know 2 things. Make sure you know absolutely clearly what the experiment is and what the outcomes look like. So again, it says we're flipping a single coin 3 times. So this is the experiment. Flip a single coin 3 times. We'll talk about the one in parentheses in a second. So when I ask students in class, okay, the experiment is you flip a coin 3 times. Someone give me an example of one outcome of this experiment. So a lot of times students will just say heads. But please understand, heads is not an outcome of this experiment. What you need to think about is you need to finish the experiment once in order to get one outcome. In other words, you have to do this whole thing that's boxed before you get one outcome. If the example was flip 1 coin, then yeah, heads could be an outcome or tails can be an outcome. But we're flipping 3 coins. So, or yeah, we're flipping a single coin 3 times. So the point is, in order to get one outcome, you have to complete this. You have to flip a single coin 3 times. So I want you to imagine we flipped one coin 3 times, and then you tell me what happened after we flipped it 3 times, and that's one outcome. So instead, an example of an outcome of this would be something like heads, heads, tails, which would mean the first flip was heads, second flip was heads, and the third flip was tails. Okay, so please understand, it looks like I wrote 3 symbols here, which I did, but that's one outcome. So in other words, again, to do this thing, once you do this thing once, you flip a single coin 3 times. If you do that, then this is an example of an outcome you can get. Think about some other outcomes you would get. See if you can come up with another one. Let me go ahead and write some other ones. Here's another example, something like heads, tails, tails. Again, that would mean on the first flip, the coin landed on heads, and on the second flip and the third flip, it landed on tails. So I really want you guys to understand that in this example, one outcome looks like 3 letters. Okay, it takes 3 letters to describe to me the one outcome. Okay, and then I wrote also, or flip 3 coins all at the same time. These 2 experiments, the one that's boxed and the one that's underlined, are almost exactly the same thing. They're not exactly the same thing. For the box situation here, we're flipping 1 coin 3 times, whereas here we're flipping 3 separate coins all at the same time. But if I said, okay, let's say you flip the 3 coins all at the same time, what do you get? Again, the outcomes would look similar to the ones that I have here. For example, let's say your outcome was tails, heads, tails. If you're thinking about it this way, we're flipping only 1 coin, but 3 times. So first flip is tails, second flip is heads, and the third flip was tails. Whereas if instead you imagine you flip 3 coins all at the same time, then this would be what happened on one of the coins, this would be what happened on the second coin, this would be what happened on the third coin. Now, if that gets a little confusing, if you're thinking of 3 coins that are identical, like we're flipping 3 quarters, take 3 quarters and throw them up in the air all at once, that gets a little confusing, you do need to remember that the 3 quarters, even though they look the same because they're all quarters, they are actually different things. Maybe they have different dates on them, things like that. So if that gets confusing at all, maybe it's easier to think of 3 different kinds of coins. So maybe a penny, a dime, and a quarter or something. So then this could be the outcome on the penny, and this could be the outcome on the dime, and this would be the outcome on the quarter. Okay, so when you flip 3 coins all at once and you tell me the outcome, you're going to just always tell me in this order. So penny first, and then tell me what happened to the dime, and tell me what happened to the quarter. Okay, so make sure you're clear again what the experiment is and what the outcomes look like. So remember, let me say it one more time. The outcomes look like 3 symbols. You have to give me 3 symbols to give me one outcome. Okay, because you have to, in order to complete this experiment once, you have to flip a coin 3 times. Flipping a coin 3 times, okay, so this is the most part. It takes 3 flips to complete the experiment once. And then once you flip 3 coins, flip the coin 3 times, you tell me what happened, and the answers are going to look like 3 symbols. So everything I'm circling here, this is one outcome, this is another one outcome. This is also one outcome, made of 3 symbols, but one outcome. Okay, so now that we're clear on that, let's go ahead and find the things that it's asking us to find in this example. So the first thing it's asking you to do is to find S. Now, normally in a problem, I'm not going to tell you what S stands for, but you know what it is because we talked about it in class. S stands for the sample space. So S is a list. So when you go to find S, you're going to put curly brackets and you're going to list all the outcomes of this experiment. So, for example, here's one outcome, heads, 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 heads. That's one outcome. And now we're going to list all of the outcomes. You want to make sure that you list them all, you don't forget any. Let me give you another one. Heads, heads, tails. And a couple ways to make sure you get all of the outcomes. One way is to do it in an organized way. Don't just sit there randomly think of outcomes, because then you're going to look and go, which one did I miss? And it might take you quite a while to figure out which one you missed. Another way is to use some counting techniques, which we're going to talk about in class soon. And the counting techniques will tell you how many outcomes there are, and then you'll know if you have if you have the right amount of outcomes, then you know you have them all. For example, I know there's supposed to be 8 outcomes in this experiment, even though I know we haven't talked about it in class yet. All right, so I'm going to go ahead and write down the other ones. So heads, tails, heads. Heads, tails, tails. What I've done there, that's basically all the possible outcomes that start with the symbol H, which that start with heads. So then now I can easily get the rest. I ran out of room and go to the next line here by just writing all the same things, but make the first symbol tails. So this is all the outcomes where the first symbol is tails. So tails, heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. Okay, so you list all the different outcomes, and that's what the sample space is. Okay, and the rest of it shouldn't be such a big deal. Probability of S. Okay, the probability of the sample space is always 1, no matter what. So there's really no work to show. Just write 1 for the probability of the sample space. And then when you're trying to find the probability of the empty set, that's another one where it's very easy. You just have to write down the answer. The probability of the empty set is always 0. Okay, so just write 0. Probability of the empty set is 0, and that's the end of the story there. No work. You don't have to show work for probability of the empty set or probability of the sample space. But I do want you to be careful. Keep in mind that the stuff that's in the parentheses is a list or an event. So we have an event here, but the answer to the probability is a number. Same thing here. We have an event here. This is a list. This is an empty list. Don't think of this as 0. That's an empty list. But the answer is 0 because the probability has to be a number. Okay, so now we're going to define some other events on this experiment and then find their probabilities. Okay, so now we're looking at the event where the first and third coin land on the same thing. So we understand what that means. It means whatever the first coin lands on, if it lands on heads, then the third coin would also need to land on heads. And so the question says to find A, which is an event, it's a list, and then find the probability of A, which is a number. So let's go ahead and start with A. So since it's a list, you're going to put curly brackets, and then you have to list all the outcomes where the first and third flip are the same thing. So here's an example. Heads, heads, heads. That's definitely an outcome of this experiment. And look, the first and third coin land on the same thing. Are there any other outcomes where the first and third coin land on the same thing? Well, we can try heads, tails, heads. Notice this description for A that's over here doesn't mention anything about the second flip. So the second flip can be anything as long as the first and third flip match. It's fine. So first and third match here. So that's another outcome. Okay, what other outcomes do we have in this experiment? Well, the two that are already there are the only ones, it seems, where the first and third coin land on heads. So it looks like what's left is all the outcomes where the first and third coin land on tails. So for example, we have tails, heads, tails. Again, those two are the same. And what else, guys? Sorry, it's looking a little sloppy here. And then the last one, tails, tails, tails. Again, the first and third match. So there's event A right there. All right, let me go ahead and get rid of these arrows to just clean it up a little bit. Now that we have A, how do we find the probability of A? Well, we have a formula for it, the classical formula. The formula for probability of A is absolute value of A over absolute value of S. Absolute value of A is the number of things in A. If you count the number of things in A, it looks like there's 4 things. 4 different outcomes in this event here. And then how many things are in the sample space total? You have to go back to the previous slide to see that, but there's 8. So in this experiment, there's 8 things in the sample space. For all the problems I do, it's going to be 8 things. Okay, so if the problem asks you to find the event A, you make this list, and here's the answer. And if it asks you to find the probability, then the answer is 4/8. All right, let's do another one. Okay, so another event. This time it says all the coins land on the same thing. So that's what B is. And the question, again, is asking us to find 2 things. B, which is an event, and then probability of B, which is a number. So this is a list we're going to find, and this is a number that we're looking for. Okay. So to find B, it's a list. So curly brackets. And let's see, think of all the outcomes of this experiment. Don't forget, we're flipping 3 times. All the outcomes where all the coins land on the same thing. Well, heads, 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 they all landed on the same thing. In other words, all 3 coins landed on the same thing. Or if we're just flipping a coin 3 times, all 3 flips landed on the same thing. What else? Yep, I'm sure you guessed it. Tails, tails, tails is the only other one. Okay, and then to find the probability of B, same formula. Absolute value of B over absolute value of S. That's why B is the number of things in B. How many things are in the event B? How many outcomes? 2 outcomes. How many outcomes in S? 8. And that's the answer to that. So here's the answer for finding event B, and here's the answer for probability of B. Okay, let's try another one. So now we have this event C. It says the second coin lands on tails. And again, they're asking us to find C, the event, and then its probability. So for C, I'm going to put curly brackets. You have to list all the outcomes where the second flip is tails. So it doesn't mention anything about the first flip. So the first flip can be anything. So one way to do it is to try to figure it out without looking at the sample space. Or another thing you could do is you can go ahead and look at the sample space and scan it and see if there's any outcomes where the second coin lands on tails and put them all in here. I'm going to try to do it without looking at the sample space, but if you need to go back and look, go ahead. So the second coin has to land on tails. The other coins can be anything. So heads, tails, heads. The second coin landed on tails there. Heads, tails, tails. Second coin landed on tails there. Tails, tails, heads. The second coin landed on tails. Tails, tails, tails. The second coin landed on tails. And I think that's it. So that's the event C. And now we're going to find the probability of C. Again, notation, absolute value of C over absolute value of S. How many things are in C? 4 things. How many things are in S? 8. Okay, so once again, there's the answer for the event. If I ask you to find C, there's the answer. If I ask you to find the probability of C, there's the answer. Okay, we got one more, I think. All right, so this is the last one in example 3. Another event, the event that the results of each flip alternate. So you want to make a list again, okay? When you're finding D, you're going to make a list of all the outcomes of this experiment where the results alternate. When I say alternate, I mean if one of them's heads, the next one's tails, the next one's heads, the next one's tails, like that. They just keep going back and forth. We're only flipping 3 times though, so let's say the first flip's got to be either heads or tails. If the first flip is heads, then and they alternate, then the second one's tails and the third one's heads. That's one outcome where the results alternate. Well, the only other thing that could happen is that it starts with the tails, and then what is it going to be? Tails, heads, tails. Yeah, so that's it for D. And then the probability of D is, again, absolute value of D over absolute value of S. Number of things in D is 2. Number of things in S, 8. Yeah, so that's how this experiment goes. There's the event, the answer for the event, and there's the answer for the probability. All right, let's go ahead and look at example 4 now. Okay, so this is an important one, so let's make sure we look at this. The question says that we're going to roll a single die twice, or we're going to roll a pair of dice once. So the point is, you're going to roll 2 die, or a pair of dice, and once you've done that, you've completed the experiment once. So for example, if I ask you, give me an outcome of this experiment, if you say 3 is an outcome, 3 is not an outcome. Because if you say 3, that's like the result on 1 die. But in order to do this experiment, you have to roll a die twice, or you have to roll a pair once. So outcomes are going to look like pairs of things. So for example, an outcome of this might be something like 3, 1, like this. So what does this mean here? Again, this is not 2 outcomes. This is 1 outcome, because the experiment says twice. So you're rolling twice, or you're rolling a pair once. So again, what does this mean? If you think of rolling a single die twice, this could be the first roll, and this could be the second roll. Or if you want to think of rolling a pair of dice, then you can think that this is the outcome of one of the dice. So this one here would be the outcome of one of them, and this is what the other one landed on. And if you're like, wait a minute, how can you tell which one's which? Maybe it's a little easier if you think of them as being different colors. If dice have the same color, it's kind of harder to think about because they're both red. It's hard to distinguish between the two, but they are different dice. So maybe it'd be easier if you're rolling a pair of dice to think of this as, this is what the white one landed on, and this is what the red one landed on, for example. Okay, anyway, so make sure you understand what the outcomes of the experiment look like. Once you get that, then the next thing is the notation. So I'm not going to be drawing the dice like this. So what else could we use? Some books use something like this. They'll put like a 3, 1 with a comma and a parentheses, indicating the first die landed on 3 and the second one landed on a 1. Some other books will use things like 3-1. Again, same thing, meaning the first die landed on 3, second die landed on 1. What I'm going to use just 3, 1 like this. I figure people will not get confused. Don't think of this as the number 31. This is the first die landing on 3, second die landing on a 1. Okay, so now that we've established the notation, let's go ahead and find the sample space. Let me go ahead and erase this mess over here. Okay, so when we find the sample space, remember that it's a list. So to find the list, you're going to first put S and then curly brackets. And I'm going to start listing all the rolls of the dice, all possible pairs of rolls of dice. So, for example, we can write 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. There's more than this, but what I'm writing here is all the rolls where the first roll was a 1. I'm going to try to do it in an organized way. You'll see why in a little bit. So what else is there? All the rolls where the first die landed on a 2. So we can write 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. And we can do this all the way down. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Keep going. 4, 1, 4, 2, 4, 4, 3, 4, 4, 4, 5, 4, 6, and on we go. So we're going to do all the ones that start with 5, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, and all the ones that start with a 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. So this one's rather long to write down the whole sample space, but I wanted to write it down so you could see it. So those are all the outcomes. It turns out there's 36 different outcomes there. You can count them. There's 6 in each row, and there's 6 rows, so that's 36 outcomes there. Okay, so that's the answer for the sample space. Real quick, let me just go ahead and write the answers for the probability of the sample space. So we know the answer already is 1. And the probability of the empty set is 0. Again, that's true for any problem. There's work you could show, but I don't really need it. You could just write that. One other thing I want to mention, though, as far as rolling a pair of dice, like when you play a game like craps, what you care about the most is the total when you roll a pair of dice. So I do want to mention that if you write the sample space exactly the way I wrote it, 6 things per row like that, then all the dice that have a certain total fall in the diagonal. For example, if I want to find all the dice where the total is 5, these are all the dice right here where the total is 5. 1, 4, 2, 3, 3, 2, 4, 1, they all have a total of 5. If I want to find all the dice that have a total of 6, you can just go to the next diagonal. Total 6, these have total 4, total 3, total 2, and like that. So this is all the dice that have total 7, so it's diagonal. The total is 8, total is 9, and you get the picture there. Total 10, total 11, and total 12. That's a nice little thing if you write it. If you write the sample space this way, if you organize it this way. All right, so let's look at some events and find them and find their probabilities. Here we go. Okay, so A says the total of the numbers on the die is 7. Okay, perfect. So again, you can go back to the previous slide and go, let's list all the ones where the total was 7. So one way to do is go to the previous slide. Another way to do it is to see if you can think of them without going back to the previous slide. So I'm going to go ahead and write A here. Total is 7. Well, 1, 6. And then what else? Well, I'm going to change the 1 to a 2. That will make the other one have to be a 5. Then 3, 4, 4, 3, 5, 1, and 6, 2. I'm sorry. What did I do wrong here? Oh. Okay. 5, 2, and 6, 1. Those are all the rolls of a pair of dice where the total is 7. Okay, and then how do you find the probability of this event? Again, we have a formula for it. It's absolute value of A over absolute value of S. Absolute value of A is the number of things in A. You can count and see that there's 6 things there. How many things are in S? We already mentioned there was 36 things. Now, we did look at this one in class. We used the empirical way of calculating the probability that the total is 7. So if I just want to tell you what the decimal answer for this is, if you put in the calculator. If you put in the calculator and write as a percentage, it's approximately 16.7%. I write it for a few reasons. One, because we saw it in class. Another is because when you play craps, rolling a 7 is kind of an important thing. So you might want to know what the probability is of rolling a 7. Okay, let's go ahead and try another one. Okay, this one says, again, same thing, rolling a pair of dice, or rolling one die twice. And B is the event that the total of the numbers is at least 11. So we have to write down all the outcomes where the total is at least 11. So if you're finding B, you make a list of all the ones where the total is at least 11. Well, the total is 11 if you roll a 5-6 or a 6-5. Those are the only ways you can get a total of 11, but it says at least 11. So it means it could be higher. So 11 or higher. So those are 11, and what could be higher? 12, you can get a total of 12. There's only one way to do that, 6-6, and you can't get any higher than that. Let's make this 6 look a little nicer. Okay, yeah, so that is event B. And then to find the probability of B, again, we're going to use the formula. It's absolute value of B over absolute value of S. How many things in B? 3 things. How many things in S? 36 things. Okay, that's the answer to that one. Let's go to the next one. Okay, so another event. The total of the numbers on the die is at most 4. At most means 4 or less. So we have to write down all the outcomes where the total is 4 or less. Okay, total 4. Here's one way. Here's another way. And here's another way. And I think these are all the ways where the total is 4. How about total less than 4, like 3? If the total's 3, here's a way where the total's 3. Here's another way where the total's 3. Those are the only ways the total is 3. How about total 2? Like this. And you can't have a total less than 2, so that's it. So that's the answer, but let me make sure you guys have this organized. So here the total is 4. Here the total is 3. Those are all the ways the total is 3. And there's all the ways the total is 2. Okay, so at most 4 means the total is 4 or less. So 4 or 3 or 2. Okay, so that's C. Once again, let's find the probability of C. Formula is absolute value of C over absolute value of S. How many things are in C? Look up there, it looks like there's 6 things. 36 total. And that's the answer to that probability. Alright, hope you guys are getting the hang of this by now. I'm sure you are. Let's go ahead and knock out the rest of them. Let's look at D. Okay, now I worded this one like this so I can be clear, but it may start to get unclear. Let's see what it says. So D is the event that the absolute value of the difference of the numbers on the die is 2. All I'm trying to say here is the difference, the two numbers on the die are 2 apart. The difference between the numbers is 2. But then some mathematician may come along and say, well, what if the difference is -2? What if you switch the order? So that's why I put absolute value, meaning the difference is 2 and I don't care which one's higher, which one's smaller. So before I go ahead and find the whole answer, if you roll something like a 3-5, we're going to say that difference is 2. If you roll something like a 5-3, I'm going to say again, the difference is 2. If someone argues and says, well, if the difference is 2 here, then the difference is -2 here, then I'm just going to say, fine, put an absolute value around it and throw away the negative. So the difference is 2 here and the difference is 2 here. Okay, so it was worded a little bit weirdly, I understand. But all I'm trying to say is that the numbers on the die are 2 apart, and I don't care which one is bigger, which one is smaller. All right, so if we understand that, then let's go ahead and list these. Let's see. So my thought process here is that I'm going to, okay, so first I'm going to write D, obviously, in curly brackets. And I'm going to think, are there any outcomes where the first thing is a 1? Well, if this is a 1, the other one's got to be a 3. So the difference is 2. Are there any outcomes where the first number is 2? Okay, 2, 4, obviously. But then when I put a 3 here, we got a couple options. It could be 3, 1, where the difference is 2, where they're 2 apart, or 3, 5, that also is 2 apart. Okay, what else? 4. If you do a 4, you can do a 4, 2, or a 4, 6. Those are both 2 apart. I'm running out of room. Let's go to the next line. If I start the die with a 5, it could be a 5, 3. Can't go higher because it would be 5, 7, and there's no 7 on the die. And then 6, if it starts with a 6, it's 6, 4. There's no other one because you would go to 6, 8. Again, there's no 8 on the die. So that's what we have for D. And again, if that's confusing, it'd be best if you can just come up with it just like that. But if not, you can go back and look at the sample space and one by one, find the ones where the difference between the numbers is 2, and you'll see that those are all of them. Okay, then I want to find the probability of D. And as usual, absolute value of D over absolute value of S. Absolute value of D is 8. Absolute value of S is 36. Yeah, that's how D goes. Okay, let's go to the next one. Okay, E says you roll doubles. When you roll doubles, it's kind of like in the game of Monopoly or something where it means both numbers. So you're rolling a pair of dice, and both of the numbers are the same. Something like 6, 6, 3, 3. So that one shouldn't be so hard. To find E, I'm going to list them all. So here's double. So you roll a 1, 1, or a 2, 2, or a 3, 3, or a 4, 4, or 5, 5, or 6, 6. Okay, and then probability of E is absolute value of E over absolute value of S. And there's 6 things in E, 36 things in S. Okay, let's try the next one. F is the event that the first die lands on 5. Okay, F for 5 it looks like. So F, you have to list all the outcomes where the first die lands on 5. So I guess it's 5, 1, 5, 2. Any outcome where the first one lands on 5. So they don't mention anything about the second one, so the second one can be anything. So let's keep going. 5, 3, 5, 4, 5, anything. So it looks like those are all the outcomes there. Okay, then ask for probability of F. Again, formula, absolute value of F over absolute value of S. And again, if you look up there and count, it looks like we have 6 things again, 36 total. Okay, let's try the next one. All right, it says the first die lands on an even number and the second die lands on an odd number. Okay, let's see if we can list all those. The first is even, the second is odd. Okay, so first is even, second is odd. There's one way. And since I realized 2 is even, I'm going to write all the ones that start with a 2 first. Try to get organized about it. You don't have to do it this way, but make sure no matter what you do, you come up with all of the outcomes. So let's see, 2, 1, 2, 3, 2, 5 are all the ones that start with a 2. Okay, and the first one's even, second one's odd. Okay, then I guess if it's not going to start with a 2 and it starts with an even, then it's going to have to start with 4. So we have 4, 1, 4, 3, 4, 5. And then the ones that start with a 6, I suppose, 6, 1, 6, 3, 6, 5. And that is the end of the story there. Those are all the outcomes where the first one lands on even, second one lands on odd. All right, and let's find the probability of that. It's absolute value of G over absolute value of S. If you count how many things are in G, it looks like 9 for this one, and 36 total. Yeah, that's how that goes. And I'm not going to do all of example 5. I'm going to do look at 3 more examples. Each example I look at, though, we're only going to do like very little of it, and again, you can do the rest after class. Okay, here it says we're going to play a single game of roulette. Let me talk to you about roulette real quick. In roulette, there is a wheel, okay? And the wheel has 38 slots in it. Actually, I have a picture here. So there's a wheel. It's got 38 slots. And then there's this ball. You see this white ball over here. And what you do when you play roulette is you spin the ball, and the ball spins around, just spins over and over and over again. And then it slows down, and then it lands in one of the slots, okay? There's 38 slots total. That means there's 38 different outcomes. This board over here kind of shows you what the 38 different outcomes are. Of the 38 outcomes, 2 of them are green. There's a 0 and a double 0. Those are green. And then the rest of them are labeled 1 to 36. Half of them are red and half of them are black. So there's 18 red, 18 black, and then there's 2 green, 38 total. These kind of numbers I need you to know for next class. So if you tell me on the quiz next time, hey, I didn't get this question because I don't know how to play roulette, I need you to know, okay? Not necessarily how to play, but need you to know certain basic things about roulette. So remember, there's 38 slots total. 2 green, 18 red, 18 black. And the ones that are red and black are labeled 1 to 36. Okay, so that's what's happening here. And every time you play, when you spin the ball, it eventually lands in one of the slots. Okay, let's go back to this. So I have a bunch of events here, and I'm asking you to find a bunch of events and their probabilities here. We'll do a couple parts of this, and then we'll move on. Okay, So let's do, I don't want to find S right now because if you were going to find S, you have to list all the slots. There's 38 of them. You have to make a huge list. So I'm going to skip that one. Let's go to B. The ball lands in a red slot. So B is an event. You have to make a list. So I'm going to put curly brackets and I have to list all the red slots. Now, I don't expect you to know that one. You should know how many red slots there are. There's 18. But which ones are red? That's actually not the easiest question in the world, which ones are red. So for that, if I ask you something like B, then I'm going to give you a picture on the quiz. So normally I don't give pictures, but if I ask you which ones are red, you're going to have to look at the picture. So just take a look at the picture. Which ones are red?
1, 3, 5, 9, 7, 12, 14.
Okay, stop. You're too fast for me. 1, 3, 5, 7, 9. All right, now let's go back. Keep going. What else?
14, 12, 16, 19.
Okay, wait. 12, 14, 16, 18. Let me write that much. Okay, so 12, 14, 16, 18. Okay, and then, yeah, so 19.
21,
Yeah,
23.
23, 25, 27, right?
Mm-hmm.
19, 21, 23, 25, 27. All right, let's see what else. What else? After 20.
30, 32, 34, 36.
Yes. 30, 32, 34, 36. Okay. So you'd have, for that one, you'd have to see a picture to know what to list. That's already a long list. Imagine listing the sample space. Okay, there's a list. Let me find another list. Let's do C. C is the ball lands in a green slot. So what goes in there? Which ones are green? So this one you should know without a picture. So let me not show the picture. Okay, I guess I can show it now, but it's on the quiz. Make sure you know it without a picture. Which ones are the green ones?
0.
0.
0 and double 0. That's right. So you just put a 0, comma, double 0. Okay, let's do one more. Let's do F. Then I'm going to find the probabilities of all these. But these are events. So you can imagine I'm making a bet and I'll win if any of these happen, or I'll win if this happens. And I want to know what's the chance that I'll win. Okay, let's go to F. The ball lands in a slot that's part of the third 12 bet and is a black number. Let's go forward. Okay, you see right here where it says third 12 right here? Okay, if you make a bet in that spot, you'll win if any of the numbers above that box come up. So basically that's the third 12 right there, any of those. I mean, think about it. First 12 is the first 12 numbers, 1 to 12. Second 12 is the next 12, 13 to 24. Third 12 is the third group of 12 numbers, 25 to 36. But I'm not supposed to list all of the ones from here. Let me change the color because it's a little hard to see. So I'm not supposed to list all of these. Okay, I'm supposed to list the ones in there that are also black. It said part of the third 12 bet that's also black. So what do I list there?
26.
28, 29.
Okay, let me write it here because I'm gonna forget. Okay. Oh, what happened? Okay, so I heard 26, 28, 29. Let's go forward. What else?
31.
1, 33, 35.
31, 33, 35. Yeah. Okay, so there's some events. Now let's find the probabilities of these events. I'll do it up here somewhere. Let's start with probability of B. The formula is absolute value of B over absolute value of S. And you start counting. Okay, so count for me. What's absolute value of B? You have to count the red slots. You can sit there and count, but you should also know how many red slots are there?
18.
18. And even though I didn't list the sample space, absolute value of S is basically asking you to count how many slots there are total. How many are there total?
38.
38.
Yeah. Okay, that's the answer to that. Any questions on that much? Okay, probability of C is absolute value of C over absolute value of S. All right, what's the answer?
2.
2 over 38.
2 over 38. Yeah, you just count 2 things in here, 38 things in the sample space. Okay, let's go to the last one, probability of F. So formula is absolute value of F over absolute value of S. Please don't forget the formula. And then you count how many things are in F
6,
and how many things are in S.
38.
38. Yeah. And anyway, there. So I did 6 parts. Do the rest of them on your own. That's the story on example 5, which is supplemental homework number 9. So again, it's that supplemental homework assignment thing. We're doing some of those problems. Any questions on example 5? Okay, let's take a look at example 6. Example 6 says we're going to draw 1 card from a deck of cards. Now, again, just like I need you to know some basic things about roulette, I need you to know some basic things about cards. Here's a picture of a deck of cards, but I'm not going to give this to you on a quiz. So know things about a deck of cards. What do you need to know? You need to know that there's 52 cards total. You need to know that there's 13 clubs, 13 hearts, 13 spades, 13 diamonds. These are things you need to know. If you focus on one rank, like 4s, there's 4 4s, there's 4 5s, 4 6s, 4 jacks, 4 aces, that kind of thing. So you'll need to know those kind of basic things about a deck of cards. Okay, so again, I'm just going to do a couple parts of this, but in the experiment in this problem, we're going to draw 1 card from a deck of cards, 1 card, and I have a bunch of events, and I'm asking you to find the events and find their probabilities. So I want some lists, and I want the probabilities. Okay, let's do, oh, by the way, when you specify an outcome in this example, you know, if you write 3, I don't know which 3 you're talking about. There's a lot of 3s. So you have to say the suit. So for a card, you got to say the rank and the suit. You got to say like 3 of hearts, okay, or 3 of diamonds. You got to say both. But in roulette, maybe you noticed in roulette, I didn't say the color. When you said 26, I didn't write 26 black. The reason why I didn't tell you the color is because there's only 126 on the board. So if you write 26, I can go look and figure out that it's black. Okay, so for roulette, when you're listing the outcomes, you only have to list the numbers. You don't have to list the color. But for deck of cards, you do have to list both, the number or whatever and the suit, because otherwise I don't know which card you're talking about. Okay, because there's lots of 3s, lots of 4s, that kind of thing. Okay, anyway, let's do A. It's the hearts. I'm going to make a list because I'm finding just event A. So we have to list all the hearts. This is how you list it. Ace of hearts. I usually just use an H. You can draw the heart symbol if you want. But I don't know. Me personally, if I ask you for clubs, this is how you draw the club symbol. But look how long it took me to draw that. I don't want to draw 13 to those. So I usually just use a letter instead. So anyway, hearts. So I want to list all the hearts. What are they? Ace of hearts, 2 of hearts. Basically what I'm doing is I'm listing everything in the second row here. Okay, so ace of hearts, 2 of hearts, 3 of hearts. Let's go back. 3 of hearts. Make sure you put commas. So 6 of hearts, 7 of hearts, 8 of hearts, 9 of hearts, 10 of hearts. And then there's a jack of hearts, and a queen of hearts, and a king of hearts. Okay, we'll find the probability of that in a minute. Any questions on that much? Okay, let's go ahead and do C. It says you draw a red face card. You have to list the cards that are red face cards. A face card is a card that has a face on them. So these are the cards that are face cards. You're not going to list them all. You're going to list the red face cards. Which ones are they?
Jack, Queen, King.
Which one?
A of hearts, Q of hearts, and K.
So these 3, Jack of hearts, Queen of hearts, 3, King of hearts. And then these as well, okay? The diamonds, they're also red. Okay, so let's go back here. So it's Jack of hearts, Queen of hearts, King of hearts, and then Jack of diamonds, Queen of diamonds, King of diamonds. Okay, one more. Let's do E. Again, I'm skipping some of them. Draw a card that has a number on it less than 5. So you have to draw a card that has a number on it. It must have a number on it, okay? It can't have a letter. So it's not no aces, no jacks, queens, or kings. It has to have a number on it, and the number has to be less than 5. So the cards that have numbers on them less than 5 are these. Again, not these. Those are not numbers. These are not numbers. And even though these are numbers, they're not less than 5. Okay, so just those we have to list. So you have to list all the 2s, 3s, and 4s. So it goes like this. Oops. So 2 of clubs, 3 of clubs, 4 of clubs, 2 of hearts, 3 of hearts, 4 of hearts, 2 of spades, 3 of spades, 4 of spades, 2 of diamonds, 3 of diamonds, 4 of diamonds. You can list them in a different order, but like that. Okay, is there any questions on those? Okay, so then let's do probability of A. The formula for that is absolute value of A over absolute value of S. Someone tell me the answer. 8
13.
hearts. How many hearts?
13.
13.
How many cards total?
50.
52.
52. Okay, let's do probability of C. Again, formula is absolute value of C over absolute value of S. How many things are in C?
6.
6 over 52. Yeah. Okay. And then probability of E, the formula is absolute value of E over absolute value of S. How many things are in E?
12.
12 over 52. And anyway, I did some of this example. You'll do the rest. Any questions? Okay. And then I'm going to skip example 7 and let's move on. Okay. So that was the classical method for calculating probabilities. And now we're going to talk about the second method called the empirical method. Like, for example, in roulette, okay, why can you use the classical method? Because every slot has the same size. That means the ball has the same chance of landing in any one of the slots. But imagine you had a weird roulette wheel where, okay, so you have some slots, like, okay, here's a wheel, and you have some slots, but then one slot is much wider than the rest. Wow, my drawing sucks. But anyway, imagine all the slots have the same size, but then there's a wide one over here. Maybe that's the 0, okay, the wide slot. Then you can't use the classical method because the slots don't all have the same width. So what do? If you wanted to find the probability that the ball lands in the 0 slot, what do? You can't use the formula. What do? The answer is you play the game a bunch of times, spin the ball a bunch of times, okay, and then you can estimate the probability with a fraction. Let's say, for example, you spun the wheel 100 times and it landed on the 0 slot 90 times because it's so wide, landed there 90 times. Then the probability is going to be 90 over 100. The bottom number is going to be how many times you ran the experiment, so how many times you spun the ball in roulette, and the top is going to be how many times it landed in the slot that you cared about, or the event that you cared about. Okay, so that's what it says over here. So to find the probability empirically, what you do is you run the experiment many times, and then to find the probability of the event, you make a fraction. The top is going to be how many times the event occurred after you ran the experiment a bunch of times. Count how many times your event occurred. The bottom is going to be how many times you ran the experiment total. Okay. Another way to write this, a different way to write this, is the percentage of times the event occurred out of all runs of the experiment. All right, here. So what I'm going to do now is I'm going to give you guys, what I would normally do in class is put people in groups, but because we're not in class, that's not going to happen. What I'm going to have you guys do is you guys are going to, everybody in here is going to calculate 3 probabilities empirically. Okay, so let me explain this first one. So here it says the experiments are going to draw a chip from a bag, and E is draw a blue chip. Okay, so normally what I do in class, I have these bags and I hand them out to different students. In the bag, there's poker chips, okay? And you're not allowed to look in the bag. What you're supposed to do is when you take the bag, you're supposed to mix the chips really well, draw a chip, and just see if it was blue. You're trying to figure out what's the probability if I draw a chip out of the bag, I get a blue chip. You just draw one chip, you write down if it's blue or not, and then you repeat. Okay, so don't do this yet, but just check out what I'm gonna do here. So everybody's gonna do this, but because I don't have bags of chips, we're gonna go to the website. So everybody do this much for now. Okay, so you're gonna go to gregsriohannamathpage.com and you're gonna click on Math 131 or 130H, whatever. Click on miscellaneous, and you see these 3 apps I have over here for these 3 different simulations we're gonna do. So everybody click on Chips app. That's the one we're working on right now, Chips app. Okay, so in miscellaneous, click on Chips app. You'll have to fill this out. Okay, let me go ahead and just fill it out for me. But fill it out with your correct name and student ID and email. Because once you do this, I want to get your results. So then you click begin drawing. Okay, here's what just happened. I've already drawn the first chip and it's red. In case the picture doesn't load, I also have it written here. It's red. So what you're going to do, let's go back to this PowerPoint here. Okay, so the trial number, this is which draw you're on. So on the first draw, did the event occur? Did we get a blue chip? For me, the answer is no. You could write the word no here, but I think to save time, the best thing to do is write 0. When the answer is no, put 0. It just saves you some time. Okay. And if the answer is 1, then you're going to put yes. I'm sorry. If it's yes, then you're going to put a 1. And now let me go to this. The percentage of times the event occurred so far. So you're going to make a fraction. Okay. I'll put it slanted because it's a little narrow there. The top is going to be how many times you got a blue chip so far. How many times your event occurred so far. So 0 times we got a blue chip so far. Out of 1, the bottom number is how many times you tried so far. So it's going to be this number. So 0%. So 0% of the time so far we got a blue chip. Okay. And then let's do it again. So let's leave here. Let's go back to the app. So now I'm going to click draw again. So now the second time I did get a blue chip. Now everyone's going to have their own results. So don't write down what I'm getting. But okay. Did we get a blue chip the second time? Yes. What's the percentage of times we got a blue chip so far? So the top number is how many blue chips we got total so far, which is 1. We got 1 blue chip total out of 2 attempts. So 50%. And you keep doing this. Okay, let me just do it a couple more times. So we'll click again. There's a third draw. It's white chip. And I know there's some blue on there, but that's not a blue chip. Okay. So on this one, we're going to write, no, we did not get a blue chip. What's the percentage of times we got a blue chip so far? It's going to be 1. A lot of people get this 1 confused. How many blue chips total so far? 1 total so far out of 3 tries, 33.33%. And you keep doing this. Here, let me do one last one. I'm supposed to do 7, but I'll just do one more. Okay, so one more draw. Okay, it was white again. Okay. So we go back to this. I'm going to put, no, it wasn't blue. Percentage of times I got a blue chip so far, 1 out of 4, which is 25%. Okay, let me do it. I want to get one more blue chip just to make sure things are making sense. Let me see if I might not get another blue chip. I'm hoping. Let's get it here. Come on. Red. Okay, let me just do 2 more. Red. Okay, and then blue. Okay. So here's what happened. So we got not blue, and then we did get blue. Okay, so for this percentage, it's going to be 1 out of 5. But then for this last percentage, we got 2 blue chips total so far out of 6 attempts, which is 33.33%. Okay, so you're going to do what I just did. You're going to do it 25 times. I only have room for 7 here. Okay, guys, so listen up. So this is really important. So I know you guys are working on watching this video and working on your lecture worksheet right now. But on top of it, I need you to do this as well before class next time. What you're going to do is you're going to go to my website, gregsjohanamathpage.com. You're going to click on the class that you're in, whichever class you're in. I'm just going to click on this first one over here. And you're going to scroll down to miscellaneous down here at the bottom. And you're going to see all these links. This one here that says empirical probability data collecting worksheet. I need you to print this out. Let me go ahead and click on it. And you're going to, you don't actually have to print it out, but it'd be advisable to print it out. You're going to need 3 copies of this because we're going to be doing 3 experiments, just like the one I just explained how to do, but you need to fill it out. And I know in the example I just did, I only was drawing chips 6 times. I need you guys to do it 25 times. Don't do it more, don't do it less. You guys are going to do 25 times. You're going to fill out this table. So you know you're going to write down, did you get a blue chip or not? Yes or no. 25 times, you're going to find your 25 percentages. You're going to fill this out. Now, you're not going to be turning this in, but I need you to do it. The minute you do it, I get the data from you. So that's very important that you guys do it before the following class. But you won't turn in these worksheets, but you're going to have to fill in 3 of these. So you do one for the chips worksheet, and then I'll explain the other experiments you're going to do in a minute. So the other experiments are over here. Okay, so it's all in the miscellaneous link. So you need this one here that says print 3 of them. Okay, so have that in front of you as you do these experiments. And I just talked about how to do the chips app experiment. Okay, and then you do the other ones. Again, you're not going to need to turn in this worksheet. You're just going to have to turn in the lecture worksheet, okay, and then the in-class worksheet when we get to that in class. But fill this out because you're going to need to have it in front of you when we discuss it later on, and especially we're going to need the very last percentage on there so we know, you know, what your guess is for the probability of drawing a blue chip, and same for the other ones. Okay, guys, so look. So these numbers over here on the right side, each one of them is a guess. I'm trying to figure out the probability of drawing a blue chip. Each number on the right side is a guess of the probability of drawing a blue chip. It's a guess. But the guesses get better the more times you draw. So drawing 6 times like I have here, you know, what's my guess? 0%, then 50%, then 33%, you know, they're getting better and better, but 6 times is not enough. Even 25 times is not enough. But since you guys are doing 25 times, your last one is your best guess so far. If you want a better guess, you got to do more than 25, but we're not going to do more than 25. So, okay. So in a minute, I'm going to need to know, you need to calculate all these percentages. It's very important you see them all, but I'm going to at least need the last answer. Okay, your very last answer. But we'll get that in a minute. Let's move on to the next experiment. So the next experiment that you guys are going to do, we're going to do the same thing again, just different experiment. This time, and this is another thing I would do in class, is I would hand out decks of cards. And your job was to draw the top 2 cards. You draw 2 cards from a deck without replacement. You just draw the top 2 cards, and you check to see if the total is 20, as in the game of blackjack. If you don't know blackjack, it's okay because the website's going to tell you if the total is 20. But the point is, take the top 2 cards. Is it the total 20, yes or no? Let me show you real quick by going to my website. So we go back to the website. And you click on this, oh, I guess I have it here, third, cards app. Sorry, I have this in the wrong order. Anyway, cards app. If you click on that, again, you have to fill all this out. So make sure you do that. And then you click begin drawing, and it'll draw 2 cards. And you could check to see the total is 14, it's not 20. So on your worksheet, you would write on this first attempt, no, the total was not 20. So far, 0 20s out of 1 attempt. So 0% so far. Let me go back and do it again. So you say draw again. The total is, so a queen counts as a 10. So a 10 and a 9, that's 19. So the total is not 20. So again, you would write on the worksheet, you would write 0. And so we have 0 20s out of 2 tries. So still my guess is 0%. And then you keep going. Let's do it again. It's possible you'll never get a 20, but hopefully you do. This total's 19. Let me do all 7 of them. So 19, so we didn't get a 20. That total is 13. That total is 11. That total is 12. That total is, count the aces in 11. 11 and a 6, that's a 17. So that total is not 20. So anyway, I never got a 20 at all, okay? But let me fake it, okay? So let's pretend I did get a 20, then I didn't, then I did, then I did, then I didn't. I'm faking it just so you can understand what's gonna happen here. So I got 120 out of 3 tries, 120 out of 4 tries, 2 20s out of 5 tries, 3 20s out of 6 tries, 3 20s out of 7 tries. And anyway, you'll calculate all these things. And this is my best guess so far. Okay, let's go ahead and look at the third experiment real quick. So the third experiment is you're gonna roll a pair of dice. So that's what we're gonna do now, roll a pair of dice and check to see if the total is 7. So, and you're gonna fill out this the same, so I won't explain that again, but let me go back to the website. So what you're gonna do, oh, here, sorry. Gotta go to here. So again, in the miscellaneous link, you're gonna go to Dice app. Again, you're gonna have to fill this out. Okay, let me fill it out. Okay, you'll click begin rolling, and you roll the pair of dice. Every time you click this button, you're rolling a pair of dice, and it tells you what the results are in case the dice pictures don't show up. And you're just going to add them and see if you got a 7. The whole question is it a 7? It says it up here too, is the total 7. So you would write a 0 for this. The next time total's not 7, no, that's a no, that's a no, that's a no, that's a no. Geez, I'm never getting a 7. Okay, there's a 7. So after my 10th roll, you get a 7. And anyway, you're going to fill out the worksheet in the same way. 0 for no, 1 for yes. Okay, and then when you're done, you're going to, let's see here. Where did my PowerPoint go? Okay, so fill out this stuff. Fill out all the percentages. Make sure you do 25 of them. So when you're done with this, with all 3 experiments, then you should have 25 numbers here, zeros and ones, 25 percentages here, and same thing for the other 2. 25 results, 25 percentages here, 25 results, 25 percentages. What I need for now, after you have your results, even though I need you to calculate all the percentages, make sure you calculate the last one. Okay, minimum, get the very last one. Okay, and then, well, anyway, actually, let me just say calculate. Okay, make sure you calculate them all. Let's go to this over here. What I want to know right now, after you've calculated them all, after you have the last answer for each one, then what you're going to do is you're going to go to my website, back to miscellaneous again, and the very last one says your empirical probability answers. So you'll go there, you'll have to fill this out, and what I want you to do is I want you to write your last answer for each one. I need all the answers, but as far as this one goes, this is what you're going to submit for today, okay? I need you to write down the last answer. What was your very last percentage for the chip one? What was your very last percentage for the dice one? What was your very last percentage for the drawing cards one? Type them all in and submit that. And then I just want to do real quick, I want to give you an idea of how good your answers are. So someone tell me what your last answer was for when you were drawing chips out of a bag, drawing a blue chip. Anybody's last answer.
36%.
Sorry, one at a time. Would you say?
36.
36%?
Yeah.
Okay. Someone else? Anyone else get one?
I got 16.
16%. Anyone else?
I got 16.
Another 16. What else?
28%.
28%
I
as
heard
well.
28. Is that what I heard?
28, yeah.
Okay. Anyone else? Okay, anyway. But your last one is your best guess. Now, it turns out, just so you know, none of these are right. But why not? Because we only did it 25 times. If you were to draw way more than 25 times, like millions of times, all these answers, all your guesses would be very close to the right answer. But still, these are all pretty close to the right answer. The actual answer for the probability of drawing a blue chip is 25%. In class, I set up the bag of chips so that there's 10 blue chips and 40 total. And so if you use the empirical probability formula, you get 25%. Every one of you is trying to guess the 25%. Some of you are too low, some of you are too high because you only did the experiment 25 times. But the more times you do it, the better. Let's look at the second one. Does anyone have their last number for the second experiment?
2 out of 25. Let me find the percentage.
So that's 8%.
I got 4%.
4%. Any other ones? That's okay. There's no other ones for now. Make sure you have them by next class. But as far as drawing 2 cards from a deck of cards, the actual probability of getting a total of 20 is, I think it's like 10.24% or something like this. So pretty good with the 8%. And again, the reason the 4% is not as close is because you got to draw more times. But, you know, we only have so much time. Let's go and look at the third one. I know it's probably, possibly no one has their answer yet, but I'm just hoping. Does anyone have an answer for the last one?
Yeah.
What do you have?
I got 6 out of 25.
Okay, so that's 24%.
I got 12.
I got
12%.
Yes.
Okay, what else?
20.
20%. Anyone else? Okay. The point is everybody in here will have one eventually. And just so you guys know, the actual probability when you roll a pair of dice of getting a total of 7 is 16.7%. And again, all your answers are pretty close to that. It's not bad, you know, 12, 24, you know, it's not so bad. But again, why is it not better? Because you have to do it more times. So if you roll the dice more times, you get a better guess. Okay, guys, so that's pretty much it for today.